Hello everyone and welcome back. I am Mr. Cobalt, and in this video I'm going to go over a couple of practice problems that deal with de Broglie wavelength and using the de Broglie equation to find wavelength or speed of a particle. In this case it's going to be electrons, but it could be protons, it could be molecules, it could be whatever, but we're going to focus on electrons. So in the first problem, it's asking us to calculate the wavelength of an electron that has a certain speed. In this case, the speed is 2.65 times 10 to the 6 meters per second. So we're going to have to use the de Broglie equation. And again, the de Broglie equation is going to be the wavelength, right? The wavelength, and that's going to be equal to Planck's constant, okay, over the mass times the velocity. And so again, the mass has to be in kilograms, and because your Planck's constant is in kilograms because we have joules. And so we are given the speed in meters per second. We need to find the mass of the electron in kilograms. You can look that up in your textbook or on the internet, but I'll look it up in the textbook. So if we look up, let's see, we have the mass of an electron. So the mass of an electron is 9.109. So the mass of the electron is 9.109. What else is there? 109, 382. Do that, 382 and something else, so times 10 to the negative 31 kilograms. Let me double check that. So it's going to be, yeah, negative 31 kilograms. So we got the mass of our electron, we've got the speed, we know Planck's constant, so we just plug everything in and we'll find lambda, which is the wavelength. So we have 6.626 times 10 to the negative 34 joule seconds, but we'll write out joules as kilograms per meter squared over second squared, and then we have our seconds. So joule seconds all over the mass, which is 9.109,382 times 10 to the negative 31 kilojoules, or kilograms, excuse me, multiplied by the speed, which is 2.65 times 10 to the 6 meters per second. And so here, kilograms will cancel out with kilograms, meters will cancel out with meters, seconds will cancel out with seconds, and so we'll have meters per second times second, right? So now these 2 seconds will cancel out, so seconds times seconds, and that's going to leave us with meters, which is what we want. So all we need to do is use our calculator to calculate this wavelength. So 6.626 times 10 to the negative 34 divided by 9.109382 times 10 to the negative 31 divided by 2.65 times 10 to the 6 equals, and I get a wavelength of 2.7448 times 10 to the negative 10 meters. And then we could convert that if you wanted to. We could convert it to nanometers, right? So remember 1 nanometer, the 1 always goes with the prefix, and then the base unit gets whatever the prefix multiplier is. Nano is 10 to the negative 9, so 10 to the negative 9 meters. And I'm going to put 10 to the negative 9 meters on the bottom, 1 nanometer on top. So if I divide this by 1 times 10 to the negative 9 equals, and so I get 0.27448 nanometers. And of course, you got to pay attention to sig figs. So I have 4, I've got a bunch here. I got 3, so 3 is the least one. So I would cut it off at 2.74 times 10 to the negative 2, or 2.7 or 0.74 nanometers. So that's the first problem. So again, we just use de Broglie's equation to find the wavelength. In this example here, they're giving us the wavelength this time, but now they want the speed. So basically, we're going to use, again, de Broglie's equation, but now we're going to solve de Broglie's equation for velocity. Okay, so now we're going to solve this equation for velocity. So multiply both sides by velocity. That cancels out. And then we're going to divide both sides by lambda. So we're going to divide here. So then finally we get the equation lambda, the wavelength, is equal to Planck's constant over mass times lambda. Oops. Lambda cancels out over here, and the velocity is equal to h divided by m divided by lambda. So now all we need to do is plug everything in. So everything else is the same as before. So Planck's constant is 6.626 times 10 to the negative 34 kilogram meters squared over seconds squared times seconds, divided by the mass. Again, we're talking about the mass of electrons, so we're going to use the mass again here. So 9.109382 times 10 to the negative 31 kilograms, multiplied by lambda, which is the wavelength, which is what they gave us here. So this is going to be 1.2 times 10 to the negative 10 meters. So I imagine that we've got a similar wavelength. It looks like we're going to be in this ballpark for speed again. So all we need to do is calculate, but let's cancel our units. So kilograms will cancel out kilograms. Meters cancels out with meters. And now we have meters left over. And oh, this is meters. Yeah, that's meters. And then this seconds is going to cancel out with seconds there. So we got seconds. So now we have meters over seconds, which is our speed unit, velocity unit. So everything looks good. So all we need to do is calculate. So once again, 6.626 times 10 to the negative 34 divided by 9.109382 times 10 to the negative 31 kilograms divided by 1.2 times 10 to the negative 10 meters equals, and we get a large number, which is going to be equal to 6061516.211, and this is meters per second. I'm only allowed a certain number of digits. I have 2 sig figs, I have a bunch here, and I have 4 there. So the least number is 2. So I have to cut it off at the 0 here. So that's a 6. I'm going to round this to 0 to a 1. So it's going to be 6.1. And then I'm going to write it in scientific notation. Or I can do 6, 1, and then the rest is 0. So 1, 2, 3, 4, 5 zeros. Or I can write this in scientific notation, 6.1, 1, 2, 3, 4, 5, 6 times 10 to the 6 meters per second. That would be the final answer. And you'll notice that my prediction is correct, that 6.1 times 10 to the 6 is the same magnitude as 2.65 times 10 to the 6. So this would be the speed of this electron. I hope you found this helpful, and if you like this video, share this video with your friends, hit the notification bell for more videos, as well as subscribe to the channel and make a comment in the comment section because it feeds the logarithm. And so thanks for joining me, and I'll see you next time.